Welcome everybody to today's FDTD Goes Applications webinar. Today we're pleased to have Ryan Sharp from the Louisville, Kentucky WFO leading today's presentation, and his presentation is titled The Use of GOES East Composite RGB Imagery and GLM Data in the Ohio Valley. Next slide. Before we begin, just a few things to go over. All these webinars are recorded and available at the URL shown here on the visit web pages. Also, we'll have a question and answer period at the end of the talk, which will take about 20 minutes. We're always looking for volunteers. If you have an interesting topic you'd like to share with the community via a webinar, let either myself, Dan Bicus, or Scott Lindstrom know. Next. So we have about 20 minutes for our speaker, and we'll have a Q&A period on the phone after Ryan is done discussing. We'll be done by 17:30 UTC. Remember, do not press hold, and remember to mute when you're not speaking. So at this point, I'll turn it over to Ryan.
All right, thanks, Dan. Thank you, Scott, also for giving me the chance to give this presentation. Just about something that's been exciting to me over the past couple years, using these RGB data set. I know that for some people it might be a little bit daunting to look at some of these data sets because just so many colors involved, but I'll show you in a second why I got hooked on this particular type of display system using one of the nighttime microphysics. But first off, I wanted to give you a brief introduction to RGBs. And this in particular is the day cloud phase distinction RGB, which is one that I've been using over the last year or so. And RGBs are just red, green, blues. They are just combinations of different products from GOES. And in this case, we have a combination of IR imagery, the IR band from GOES 16. It gets color to red color. The visible band, the 0.64 micron band, gets a color to green. And the snow ice band gets color to blue, and they all get merged together into this one image. And what you're seeing here is actually several different layers of clouds. And in this light blue or cyan color, you're seeing basically your liquid water droplet clouds. These are your lower clouds. In the green, you're seeing some clouds that are beginning to glaciate. They're getting tall enough to get to that point where they have some ice in them. And then the yellows and the oranges and the pinks are where you have your pure ice. So you see your taller clouds in there. And again, there's a bunch of two-pagers that are on all these RGBs and all the different satellite bands that are really easy to get to from that website, or you can just email me if you ever have any questions about them. How do we use this in operations? I actually used this for decision support services for the TAFs that I was doing on this particular day. We have 4 TAFs here in the Louisville County Warning Area, Louisville, Standiford Field, Lexington Bluegrass Airport, Bowling Green, Warren County Airport there, and then a new one that we just added is Huntingburg. And on this particular day, we had a convergence boundary up here. We had some storms that were forming over Jackson's area in the east, and we had one little cell pop up in this in the vicinity of the Bluegrass Airport. If you look at a couple other products that you see from GOES, you can also get some derived stability indices. And this is the lifted index, showing a relatively more negative band that happened to be right alongside where that band was forming. So at this point, I decided to change our forecast, which was thunderstorm-free, to add in a vicinity thunderstorm. And so that's just one of the many ways you can use some of these products to be able to add some decision support services. Here's another look from that day cloud phase distinction RGB, and this was after a system went through here, kind of overachieved for us. You see the remnant boundary that happened. This was 1546, so this is about 10:45 in the morning for us. And you see these low clouds that have been left behind, but in the wake, they did create this snow band, which shows up in green on this RGB. And this was an overachieving snow band. We were barely considering it maybe an advisory at this before this came down, but it overachieved. We got 5 inches of snow at most there in Casey County. Warning level for us is 4 inches or more. So it was definitely an overachieving band, and you can just see it shows up really nice, especially anybody who's been in the Midwest or in the Plain States. I'm sure they've used some of these and seen much more impressive bands than what we have. Another RGB here is the nighttime Microphysics RGB, and this is the one that I got started on using a lot because I really like being able to see the fog in a lot of the river valleys over Jackson's area. You got the Ohio River coming up here, the Kentucky River, and you see the fog forming on given nights. So I usually leave this one up whenever I have a night shift and I'm working, and just keep it up in the background. But on this particular night, this was back a little this popped up in Greene County, in northern Greene County, so it piqued my curiosity. I wasn't sure what I was seeing. I thought, maybe it was a fire, and so I decided to call the 911 dispatchers in that area to see, what are you seeing? And at the time, they didn't know anything about a fire going on in that area, and they still didn't have anything. They didn't suggest that they were going to do anything about it. Because I actually, when I was talking to them on the phone, I said, I'm not sure what I'm seeing, but it looks like there might be a hot spot there. So later I messaged somebody who I know that works with the Greene County Emergency Management Office, and just said, hey, this might be a strange question, but can you find out if there was a fire at this location? I was able to give him an approximate location. And he confirmed there was a large structure fire. There was a barn that was full of hay that did burn down, and that they didn't find out about it until about 30 minutes to an hour after I had made that call to the 911 dispatchers. And so it was pretty interesting to me that we had this, and he was excited about it, that we could pinpoint what was going on. And so it sort of became a mission of mine to keep looking out for these little hot spots. And my MIC here calls me Smokey because I like to look for all of these. Here's another one that popped up in Adair County, in northern Adair County. And again, in this case, I called the dispatcher, and they hadn't heard of any issues, so they were able to send somebody to the location that I gave them. And we had a good quote from the Adair County emergency manager saying this new satellite, what we're seeing is these high-resolution imagery. We're able to see some of these hot spots. And he said it may have prevented a large wildland fire. This was mid-December of last year, which happened to be our wettest on record. So I wasn't too worried about a large wildfire. But just in the last couple months, we've gotten into a flash drought here. And so we've been seeing a few more of these hot spots pop up. And you always have that question, is this hot spot going to become something that's a wildfire that's going to be a problem? So we got some good praise from that one. And again, if you see one of those spots, you can get the lat lon from it, and I just plug it into Google Maps. First off, to make sure that I'm not looking at a power plant that may be just turned on that's generating a lot of extra heat, because that does happen. There's one up in north of Cincinnati that generates heat all the time, and it's easy to see. But also to be able to just give an approximate location. In this case, the road, this was a pretty rural area, and Mount Tussle School Road was the road that went through here. And I said, hey, this is where I'm seeing the hot spot. And they were able to send somebody out there and, again, confirm that there was a fire going on in a pretty rural location. And over the course of a little bit over a year, I've gotten out of the calls. Actually, we had several fires a couple nights ago, so that even this number is a little bit out of date, but we got probably about 90% of the calls that I've made the dispatchers have been confirmed fires going on there. A couple other little interesting cases, looking at, in this case, there was I-64, which runs from Louisville to Lexington, and this is the city of Shelbyville. There was a hot spot there early one morning, and I called them, and they said, yep, there was a semi-truck on fire just off of the Shelbyville exit. And then this one was more in the news a couple months ago. There was a large gas explosion at just in the middle of a field off of Danville there. And I didn't catch this one early on, but believe me, everybody that was there did catch it, because this webcam, we have a webcam monitoring program here, and this was 10 miles away, showing you the fire that was there. And it persisted. It was this bright for a while as they were trying to get the fuel shut off. But this one made a lot of good news coverage in that area. Fortunately, just a few, I think it was just one fatality and some injuries with this. But again, it was just a gas leak that went on from there. So something else you can see from the nighttime Microphysics RGB, this is power plants along the Ohio River on a winter night. All of these different streamers that you see coming down are different power plants. And it's just kind of neat, the increased resolution that we have with this new series of satellites. There's going to be things like this and many other microscale meteorology features that we're going to be able to identify. But the challenge to all of you that use these products is to just go up and look at these different things and try to figure out the reason behind them. One of the NWA talks that I listened to was from a broadcast meteorologist team in Cincinnati. And they were talking about one of these streamers was persistent for all night, and their forecast had no snow for the whole night, but there was a 4-inch snow total down in Dry Ridge, Kentucky, out of one of these bands. And so, of course, they get all the hatred from the viewers saying, "Y'all told me it wasn't going to snow," but then you end up with something like that. So these are just some neat things that we can follow and we can figure out by looking at some of these high-resolution products. Another application, again, this is the nighttime microphysics. In the evening on a pulse thunderstorm type day, and you can see the outflow boundaries coming out of these thunderstorms. Down in this area, Lake Cumberland, in our southeast forecast area, it's actually not really good radar coverage there. So let's say we were to have a squall line or a QLCS coming in from the west. If you were to start seeing that outflow push out ahead, then you can understand, even in that poor radar quality area, that the line of storms is weakening. So this could prove real useful, especially if you have the mesosector over you, that it could be real good for your situation awareness of what's going on. I'll switch gears to a different RGB. This is more, actually this was in the early stages of when we were getting our products. And one of the other forecasters here, Brian Schuttmer, noticed something that was interesting. Jefferson Proving Ground is this sort of forested area that's in our far north CWA. We share that with Wilmington and Indianapolis. But in this case, this was early in the afternoon, about 12 o'clock there, 1 o'clock there. And as the day went along, we noticed right along that boundary was where the cumulus field was beginning to develop. So you had a little bit of a differential heating boundary that was in that area, and that's where your clouds were forming. So we're going to saw all of this microscale meteorology stuff in the future, and it's just really exciting time for us to be able to work at the forecast side to be able to see all of these things. So I'm going to switch gears a little bit, going over to the GLM data. I'm going to present a case study that I worked. It's the first day that we got the GLM data, and again, this is one of those hooks that got me interested in it. I was working the evening shift, and our IT was able to install the product, and so I immediately put it to work. And pulse thunderstorm time around here is pretty difficult because it's really hard to say which storm is going to be just a special weather statement worthy, if at all, and which ones are going to be your severe thunderstorms. And in this case, we had several pulse storms earlier in the afternoon with a lot of these light blue colors. The background here is your flash extent density, and that's just showing you how many flashes are going on over a 5-minute period in this case. So this storm never really had a lot of lightning as it was going over Lexington, which is Fayette County right here. But it did persist over the eastern part of the county, and we had just issued a flash flood warning because of that persistence. But once the storm started to develop a little bit more on the east side and push eastward, we started to get a little bit of a tick up in the lightning activity. So I went from the SPS that I had, and I upgraded to severe thunderstorm warning. And I collaborated with our neighbors because that storm was headed towards the Jackson area, so I was making sure that they were aware the reason why I was issuing a warning. As you go forward in time, it really had a lightning jump, and that's one of the key factors that we've been trained on. As you see these big lightning jumps, it shows you have a better updraft, and there's a better chance for some severe weather going on. So this jumped up to 86 flashes in a 5-minute period of time. Notice, too, my box is here, and my lightning is here. That's just the parallax issue. Over here in Kentucky, from goes east, we have about a 5 to 10 mile north-northwest parallax for the lightning from where the storm actually is. And some ways to mediate that, which I did after this case, was to throw on some of the actual ground truth, like the ENTLN and the NLDN data sets, so that you can compare what's actually going on cloud to ground with these cloud event flashes that are going on. Continue on in time, as it was about to cross the border into Jackson's area, we jumped up to 114 flashes per 5 minutes. So this was definitely a severe thunderstorm, in this case. Now, not all cases where you see these high values are going to be severe, but you have to keep it with both a lightning jump and keep it relative to other events that are going on. But for a pulse thunderstorm afternoon, this was clearly severe. And it turned out that that was the only severe weather that we had in the state of Kentucky that day. And there's actually several reports, both in Clark County, which is this county here, and Powell County to the east. Several trees got downed, roof blown off a house. So this is a pretty strong wind gust that came out of this storm that was going through. So I'll end with this slide. Actually, I have a couple more slides since I have some time to show it, but this is back to that nighttime microphysics, and I just thought this was really cool to see. You have your river valley fog going on in eastern Kentucky, and at this point we had a cold front coming through, and you can just see it sort of erasing the fog as it was slipping through. And I'll just show you this quick link to those RGB guides showing you what each of the different colors means, and there's one of these for each of the different RGBs that are available in AWIPS. And if you wanted to show somebody that's outside of the Weather Service network, there is a public-facing web page here with Colorado State, and you just pick your product, you pick your sector, and it shows all the various things that are available. And so that's really useful there. So in summary, again, RGBs take some getting used to. They can be daunting, a little bit overwhelming, but I challenge you to at least give it a try and maybe just get used to one at a time. Right now I'm moving on from, I have the nighttime microphysics, the day cloud phase distinction, but I'm also looking at the fire temperature one, which is helping us with some of these fires that are going on. And I'm also looking at the differential water vapors. So trying out some different ones and see what else I can get, because there's just a ton of data coming in from GOES-R. And what you have to do is try to merge that in some way that makes it more usable. Instead of looking at all 16 bands, try to find different ways to see things. And we're going to see some things that we've never seen before. And it will help us with DSS, and it might even help, I didn't talk about it here today, but let's say you're watching just the clean IR band by itself, and you're watching thunderstorms that are developing, and you see overshooting tops. And since we're getting the data every 1 minute or 5 minutes, depending on your sector, that could help you to pull the warning if you had to in any of those cases. So, again, if you have any questions, just let me know, ryan.sharp@noaa.gov. So with that, I'll turn it back over to Dan.
Okay, any questions or comments for Ryan?
Hey, Dan?
Yeah, go ahead.
Yeah, this is Steve Goodman from GOES-R program. There's a new public-facing website that Nesda Star has put out for GLM and ABI, and so, you might make that aware to people to check out.
Okay, sounds good. I'll look for the link on that and make sure we get that out there.
Yeah, nice case, too. It's nice to see the outflow boundary at nighttime.
Yeah. These are all really neat things. It's like I said, it's just something that we're going to see more features than we've ever seen before based on this satellite, and I really appreciate it.
Any other questions or comments for Ryan?
This is Scott. I just have a comment. When you're looking at fires, it's nice that it shows up in those RGBs, but it'll also show up in the single band because it is generally just coming from the 3.9 micrometer band 7, the shortwave infrared. There are lots of different ways to look at the data. That's one of the nice things about GOES-R is you have RGBs, you have single channels, you have products. Any one of those are going to give you similar information, so just use what you're most comfortable with.
Yeah, I passed that on to the office. The 3.9 micron band, it's pretty good as well as seeing the fires. But if you go through those transition periods where you're at sunrise, sunset, I usually have both that up and the nighttime microphysics, and it sort of stands out a little bit better in the nighttime one.
Okay, thanks.
Any other questions? Okay, well, thanks, Ryan, for leading today's webinar. And with that, we'll conclude the webinar, and everybody have a great day.
Thank you.